Hello everyone, this is Uday and welcome to Uday Lectures. In this video, we will discuss about a BTree data structure insertion operation. BTree insertion operation can be performed very similar to the binary search tree insertion operation, but where exactly it differs is we trying to balance the tree after we perform an insertion operation. So the insertion operation steps for BTree goes like this. So just similar to the binary search tree. So the insertion of new node can always be done only for the leaf nodes. So you can insert a new node only at the leaf node position or as a child for the leaf node position. It is very similar in binary search tree and also it is very similar in AVL tree just like BTree. Alright. So in BTree also we will be doing the same. And what exactly should we do after we insert a new element? So after we insert a new element, we should make sure that the properties of BTree are satisfied, right? And to do that, so we are going to check them. So once the insertion is done, so we have to validate all the properties of BTree. So if you are not very sure the properties of BTree or the rules of BTree which must be satisfied, I already made a dedicated video for BTree introduction and wherein I have explained the properties of BTree that must be satisfied and what operations we are going to perform in balancing the tree, right? So if you have missed that video, do watch that video. And after we validate the properties of BTree, so if rules of BTree is violated, so if the rules are not violated, then we don't have to worry about balancing the height of a tree. And if in case the properties of BTree are not satisfied, that is when we have a problem called the height imbalance. And to balance the height of the tree, we have to perform this particular operation. So we have split operation and merge operation in BTree, which is used to balance the height of a tree. And in insertion operation particularly, we will be making use of split operation, and using split operation we will be able to balance the height of a tree. However, just to quickly rephrase what split operation is, let us say I have the present node like this, so wherein I have elements like this 5, 1, 10. So let us say the order of the tree is 4, and in this case the maximum of keys that are allowed in this particular tree is 4 minus 1, which is 3. This I have already explained how you calculate maximum number of keys, minimum number of keys, maximum children, minimum children in the previous video. Do watch that video to understand better. So here let us say if I'm asking to insert a new element called 15 now. Here we will be checking the maximum number of keys. The maximum number of keys here is 3. So I don't have to worry about anything. It is still following the properties of BTree. So let us take one more element to insert. Let us say 20. So what happens now? So we have more than the maximum number of key values that are allowed in the particular node in BTree. So here we are going to perform split operation. So to perform split operation, you will be calculating a median position. So after we calculate the median position here, so the median position is this particular element, which is second position. So now what we do is we take 10 as the root node or parent node, and we will be splitting the left part as left subtree and right part as right subtree. So here the tree will be changed into this particular structure. So we'll have 5 as left child and we have 15 and 20 as right child, right? So this is how the split operation actually work. So the split operation is very simple. All you have to do is check whether the maximum number of key properties being satisfied or not. If it is not satisfied, that is when you have to calculate the median position, and the median value will become the new parent, and left part will become left child and right part will become right child. So this is how split operation actually work. But do remember, the insertion of new node can always be done only in the leaf node. We cannot insert them in the parent node or internal nodes. So this is something which has to be remembered. Now we will quickly understand a real-time problem. We will take series of numbers and we will try constructing a B-tree using the insertion operation. We'll come across various situations in them. So do watch the video till end so that you will understand the problem better. And in exams, they will be questioning you by giving a problem and they will ask you to solve constructing a B-tree for the given list of numbers. So here I have considered a list of numbers and we are going to construct a B-tree for this list of numbers. To insert 6, so since the present tree is completely empty, I can go ahead and insert 6 directly. So I can go ahead and insert 6 directly. Okay. So do represent the nodes in B-tree like this. But before we solve this problem, we should understand what is the minimum key value, maximum key values, and child and maximum minimum child values. For that we need something called order. So let us say for this given problem the order m equals to 4. Okay, so for m equals to 4, so the maximum number of children that are allowed is 4 itself, which is m, and the minimum number of child nodes that is allowed is, so 4 by 2, so which is 2. And coming to k maximum, which is nothing but maximum number of keys that are allowed, so which is m minus 1, so which is 4 minus 1, and that is 3. And now coming to the minimum number of keys that are allowed is, that should be satisfied is c minimum minus 1 or m by 2 minus 1. So what is m by 2 minus 1? Which is 4 by 2 minus 1, which is 1. So now these are all the properties which we must make sure that these are not violated. Okay, so this is very important in construction of BTree or in performing operations in BTree. Okay, and what is the one other important rule? So all the leaf nodes must be in same level. All the leaf nodes must be in same level. So these are all the properties in total, and we should make sure that all these properties are satisfied whenever we perform some operation in BTree. So now let us go ahead and solve this problem. So here the first value is 6 and I can insert 6 directly. And now let us go ahead and insert the second element. So what is the second element? So insert 4. So to insert 4, I can go ahead and insert that value first, and we have to make sure that the values are sorted. Whenever we are inserting a new value, we should make sure that they are arranged in a sorted fashion in a node. So here 4 is less than 6, so I am inserting 4 to the left side of 6. And after insertion, we have to check whether it is violating the maximum number of key values or not, because in insertion operation this is the only property which is in danger, so which is going to be violated, and that is why we should make sure that this particular property is satisfied. And if this property is looked after, then the all properties will also be following along. So here the maximum number of keys that are allowed in this particular B tree is 3. So here I have only 2, so I don't have to worry about balancing the tree. Now I can go ahead and insert the new element. So what is the second element or third element? So the next element that we should insert is 24. So the present node is 4 and 6. Now I can insert 24 here because 24 is bigger than 4 and it should go to right, and 6 is bigger than 24 is bigger than 6, so it should go right side of the 6. And this is how we insert the new value into B tree node. Now it will get interesting after we insert 11. So let us see what happens. So insert 11. Okay, so to insert 11, so we'll have to consider this particular node first. So we have 4, 6, and since 11 is bigger than 6, it goes here, but it is smaller than 24, so that is why I have inserted that here. Okay, now if you see, it is violating the maximum number of keys. So what are the maximum number of keys allowed in this B tree, which is 3. So it is more than, there are more than 3 values here. So what is the number of values here? There are 4 key values. And what we have to do in this case, we have to perform split operation. The split operation is performed when the maximum number of key property is violated in the B tree. Okay, so what do we do in this case? We will try and calculate the median position. So what is the median? So if you divide 4 by 2, the value is going to be 2. So now what we do is we will be considering this second value, and we will make this second value as new parent, and the left part will become left child and right part will become right child. So now the tree is going to be converted into this particular structure. 6 becomes our root node, it goes to the higher level, and 4 which is the left part is becomes left child, and the right part which is in this particular node becomes the right child. So this is how this insertion operation is going to work. So we just perform split operation when the maximum number of key property is violated. Okay, if this property is violated, that is when we will perform split operation. And to perform split operation, we have to calculate the median position. Median position is nothing but the size of the present node divided by 2, and that will give us the median position, and considering that median position, we will perform this split operation, and this is how this split operation is going to work. So now let us go ahead and insert next value. So what is next value? 0. So we'll try inserting 0 now. Insert 0. So here if you see 0 is smaller than 6, but some of us will understand like, sir, why can't we insert 0 right here? So the problem is this. So in BST, the insertion operation can be done only for the leaf nodes. So we can insert a new element as child node for the leaf node. So here the leaf nodes are only this 4 and 11 and 24. Only for this we can insert a value called 0. And here, so we can insert, since 0 is smaller than 6, it goes to the left subtree, and here we can insert 0. Okay, so since 0 is smaller than 4, it can be inserted right here. Okay, after insertion only we should check the properties of BTree. Now the insertion is performed. Now we should check the properties of BTree. So what is the K maximum? So the K maximum for this particular tree is what? 3. So here if you see, so here we have calculated the K maximum. Okay, so here if you see, the maximum is 3, but here we have only 2, so we don't have to worry about balancing the height of a tree. Now we are happy and we can go and insert the next element. So what is the next element? 15. Okay, so we will insert 15 now. Insert 15. Okay, so now the present tree is this. So where 15 can be inserted? 15 can be inserted right at this position. Okay, so let us go ahead and insert that first. 6. We are not worried about left subtree because 15 is not going to be getting into right subtree. So 15 is bigger than 6, so it has to be inserted only in the right subtree of 6. So 11 and 15 comes here because we have to sort them in an order after insertion. Okay, now if you see, 15 is inserted right here. Now insertion is completed. Now we should validate the K maximum. So what is K maximum? 3, and it is still within the property value of 3. So we don't have to worry about balancing or split operation. So now we will see what is the next element to be inserted. We have inserted 15, now we will insert 9. Okay, so we'll insert 9. So inserting 9 now. So we have 6, we have 0 and 4. Since 9 is bigger than 6, it has to be inserted only in the right subtree. So we'll come here and we have 9 inserted right here, and 15, and then 24. So now insertion is completed. Now we have to check the properties of BTree. So K maximum is 3, but what is the K value here? In this node, the K value is 4. So since the K value is exceeding the maximum property, so now we have to perform the split operation. So just similar to this case. So here we have performed split operation when the K value is exceeding the K max. So K max equals to 3, right? And how split operation is performed? We will calculate median position, and then we will push that median position value as parent node, and the left part will become left subtree and right part will become right subtree. Okay, so now we will try and split this particular node. Okay, so after split operation, so the median position, what is the median position here? Median position is 2. So the second value, what is second value? Second value is 11. So 11 has to be pushed to the parent. Okay, now 6 and 11 will be one node. Okay, and 0 and 4 are the left child of 6, and what is the left child of 11 is going to be? Left child of 11 is going to be 9. And what is the right child of 11 now? 15 and 24. Okay, so this is how the split operation actually works. So after this particular step, we have to check the K max in this particular node. So in this particular node, the K max property is still intact. So the number of key values are only 2 and the maximum are allowed is 3. So if in case if this is violated, and we have to perform split operation for this particular node. All right, so do remember that. So do not worry, we'll end up in that situation also when solving this problem. We will see what should we do in that particular situation. Okay, so the next element that we should insert is 13. So we have inserted 9 and now we will insert 13. Okay, so inserting 13. So the present tree is this. So let us insert the new value into this particular present tree. So 6, 11, 0 and 4 are the left childs. We have 9 as right child, and we have 15, but 13 comes here before 15 and then 24. So the new value is inserted in this particular node because this is where 13 is going to fit, because 13 is bigger than 6 and it goes check in the right part, and right to the 6 is 11, and again 11 is smaller and 13 is bigger than 11, so it has to be inserted in the right subtree of 11. So in right subtree of 11 we have inserted 13 and we have sorted those values. Now check the Kmax property. So Kmax property is 3 and the maximum number of values that are allowed is 3, and it is still intact, so we don't have to worry about any height balancing operation. So we will insert the next element. What is the next element? After 13 we should insert 5. So we'll insert 5 now. Okay, so inserting 5. So 5, where will the 5 go? So 5 has to be inserted in the left subtree of 6 because 5 is smaller than 6, right? So here in this particular node 5 can be inserted. So this is how 5 has been inserted, and 9 stays as it is. We have 13, 15 and 24. Okay. So here the Kmax property is checked for this particular node. If you see the Kmax property, so it is not violated, which is 3. Okay, so the K value is 3 and the Kmax is also 3, so it is still within the property level. We don't have to worry about any height balancing operation. So we will insert the next element. What is the next element? Inserting 2. So we will try and inserting 2. So we'll insert 2 now. Insert 2. So where will the 2 go now? Again to the left subtree of 6. So here 2 can be inserted for this particular node. So here if you see, the property of BTree is violated. I'm just completing this tree. Okay. So here if you see, the Kmax property is violated. So the maximum allowed is 3, but here the number of key values are 4. So what should we do? We should push the median position, which is the second position, to the parent node. So now 2 will go up and left side will become left subtree and right side will become the right subtree of 2. So we will perform the split operation here. So we will write split operation is performed. So here 2 will go up, 6 and 11 stay in the same positions. Now, what is the left part of 2? Left part of 2 is 0, it becomes left child, and right part of 2 is 4 and 5, it becomes the right child. And what is the right subtree of 6? So, which is 9, and the right subtree of 11 is 13, 15 and 24. Okay. So, this is how the split operation works. Now when the split operation is performed, we have to check the Kmax property for this node, so which is the new parent node. So here the Kmax property is 3 and the number of key values are 3, so they are within the range, so we don't have to worry about any further split operation. So now we will insert the new value. After inserting 2, what is the next value? So the next value is 45. Now we'll insert 45. Okay, inserting 45. Okay. So where will the 45 go now? So 45 will go to the right subtree of 11. Okay, and I'll just quickly copy this. Okay, so here if you see, 45 can be inserted for this node. So 15, 24 and 45. Okay, so this step is going to be interesting, so do watch carefully. Okay, so we have 9 here, we have 9 here, and then we have 4 and 5 here, and then we have 0 here. Okay, so here if you see, the Kmax property is violated. Yes, so the Kmax property is what? 3. But what are the number of key values that are there in this particular node, which is 4? So what should we do? We should try and push this 15, the median position I'm sorry, median position, into the parent node. So here if you see, this particular node wherein the splitted value has become inserted, so which is the new parent node now, since it is violating the properties of Kmax or the BTree properties, so we have to perform split operation again on this particular node. So here the median position is 2. So what is the median position value now? So the median position value now is 6. Now you have to push 6 as root node. So now 6 will become the parent of this particular node. So we will perform that particular step now. So 6 becomes our new root node, and we have left part as left child. And what is the right part of this particular 6? 11 and 15. Now this will stay as right subtree or right child. Now what happens to this node? So this nodes will be connected as it is. Now 0 is connected as left child of 2. Here if you see, right? Here if you see, 0 is connected as left child, and what is the right child of 2? 4 and 5. So now 4 and 5 will become the right child of this particular 2. Now coming to the left child of 11 is going to be 9, and what is the right child of 11? 13, and then right child of 15 is 24 and 45. Okay, so now if you see, the K-max property is not violated in any of the node in B-tree. So this is how you have to perform the split operation. And the split operation, you cannot just be like, I have performed one split operation and I'm just done with the split operation or balancing the height of a tree. No, it is not that case. You have to perform or keep performing the split operation to make sure that all the nodes are having within the limit of K max, or which is the minimum or maximum key values are satisfied. Okay, so this properties must be satisfied. Here if you see, we have inserted 45 in the present tree, and after inserting 45 we got this particular node violating the property of B tree, which is K max property. So what did we do? We performed split operation, and after performing split operation, this particular node is violating the properties of B tree. So here if you see, the maximum number of key values are exceeded. Again, what should we do? We have to perform split operation in this particular node again. So now after performing the split operation, that is when we will get this particular tree. So here if you see, in this tree, none of the nodes are violating the properties of B tree. So now we are okay with this particular tree. So now we will insert the next element. So what is the next element? 63. So the last element. Let us try and insert 63 now. Insert 63. Okay. So to insert 63, so it has to go to the right side of 6, which is 11 and 15. Now again, so it will be compared with 11 and 15. After comparing with 11 and 15, we will get to know that 63 has to be inserted to the right side of 15. And here we will insert 63 because this is the final leaf node in this particular subtree. So we have 24, 45 and 63 can be inserted right at this position. Okay, now let me complete the other parts of the tree. So 2 here, 0 here, 0 here, and then we have 4 and 5 here, and then we have 9, and here it is 30. All right. So here if you see, the K-max property, it is still intact, it is not violating the K-max property, and if we insert one more node, that is when the property is going to be violated. So that value is not in the problem, but just for you to understand, I'm trying to take one more value now. But in insertion operation, this is the only situation where you will be confused yourself, and this I hope you have understood this particular insert step. Okay, now we will insert one more value. Let me just take one more just for our understand. Let me try inserting 100 now. Okay, so here if you insert 100, let us see what happens. Insert 100. Okay, so for inserting 100, where will the 100 can be inserted? 100 can be inserted right here. So let us go ahead and insert that first. 6 comes here, 11 and 15. Do remember that insertion can be done only in the leaf nodes, right? We cannot insert them in the internal nodes or parent nodes. 63 and 100. Now here the property is being violated. Okay, here the property is going to be violated. What should we do? We should try and perform split operation. So in performing split operation, the median position, which is 45, is going to go up to right this position. And after this, we have to check the K-max property right here. If it is violating, we have to perform the split operation again. Okay, so let me complete that now. So here 6 stays as it is, 11 and 15. Okay, so now what happens after this split operation here? So 45 will go up, 45 goes up, and whatever left in the left side of 45, which is 24, is going to become the left child, and 63 and 100 is going to be the right child of the 45, and the remaining nodes will be in the same position. So here if you see, 15 is having a left child, which is 13, and 11 is having a left child which is 9, and then we have 6, a left subtree which is 2, and for 2 we have 0 as left child, and for 4 and 5 as right child. Okay, now here if you see, we have performed the split operation, the parent went up, and here if you have inserted one more, it is still going to be same. If you insert two values, that is when it is going to go up, and again it has to be split because one more value will violate the property of k max in this particular node. Again that median value position which is 15 is going to go to the this particular node, and that is how the insertion operation is performed in BTree. Hope you have understood this BTree insertion example and how you can construct a BTree for the given list of numbers and different situations that you will come across. And if you have any doubts in this particular topic, do mention that in the comment section so I can respond back to your comments. And if you like the content of this video, do like this video so that this video can be recommended to many others. And if you want me to make any videos on any of the required topics, do mention that in the comment section. And do share this video if you feel this video is worth sharing with your friends who are struggling to understand the advanced data structures topics. And please do subscribe to the channel so that you will be notified with further content.